Hello again, everybody. Thank you for tuning in to another video. And in this one, we are going to be talking about how I ported NetHack to my operating system. So, if you don't know what NetHack is, I'm going to show you. It's basically a dungeon crawling video game with a text-based interface. So, let's go ahead and boot it up here. Who are you? I am Kata. Should I pick your character's race, role, gender, and alignment for you? Let's go ahead and hit no on that. So it's essentially a role-playing game. You go around this dungeon, and the dungeon is completely randomly generated. And you pick a class and you pick a race, and you're given a random starting scenario basically, and you run around the dungeon, and you can kill monsters, gain experience, loot treasure, talk to NPCs, yeah. So let's go ahead and let's go with the wizard this time. I'm going to be a let's do random, and random for that as well. Neutral or chaotic. Let's go ahead and do chaotic. I'm a chaotic wizard. So Cat is a chaotic male human wizard. Let's go ahead and start our game. It's written in the Book of Anur. After creation, the cruel god Moloch rebelled against the authority of Marduk the creator. Moloch stole from Marduk the most powerful of all of the artifacts of the gods, the amulet of Yendor, and he hid it in the dark cavities of Gehenna, the underworld, where he now lurks and bides his time. Your god Anur seeks to possess the amulet and with it to gain the deserved ascendance over the other gods. You, a newly trained evoker, have been heralded from birth as the instrument of Anur. You are destined to recover the amulet for your deity or die in the attempt. Your hour of destiny has come. For the sake of us all, go bravely with Anur. And then we can just run around the dungeon. So your player character is represented by this little @ sign, @ symbol. It's obviously all text-based graphics. I haven't got an actual video graphics up and running yet, but you can move around, and it usually gives you a little animal that follows you around as well. So as you run around the dungeon, you can go and loot things. I don't actually remember the controls for this very well, but you have extreme difficulty lifting a human corpse. Continue. No. You hear a human corpse. A little dart shoots out at you. You're almost hit by a little dart. Oh my goodness. Alright. Let's see here. So, anyway, that's a little demonstration of how this game works. Can drop the gold piece. Wow. Dart. No. The dart trap here. The dart shoots out at you. I'm hit by the gold dart. The dart was poisoned. Oh my goodness. I'm now poisoned. So, you get the idea. I run around this little dungeon. I think there's a door. There. Door opens. Open the door. Get on the floor. Everybody walk the dinosaur. Yeah, okay. So, it's a little text-based, dungeon crawler. And, this is running on my operating system. I still can't believe it. So in order to get this up and running, I'll show you what I had to do. So first things first, before I was having issues with the serial interface. So I don't know if you realized, but before this video, I was using a Minicom to to basically SSH, even though it's not over the network, but a serial, TTY interface into my operating system from a local serial port that was opened up by QEMU. And that was causing me some problems. It worked fine for programs like V or VI, mostly fine. But for applications that use lots of ANSI escape codes, such as NetHack, with its ncurses or curses interface, that was causing me some issues. So I basically, in order to fix that, I decided to ditch the serial interface, go with the VGA graphics. The only issue was, in order to use the VGA text mode in my operating system, I could not figure out how to get it to work with Lamine, so I ditched Lamine, basically. I uprooted the entire bootloader and used the same bootloader that I used in my old version of k4dos, which is right here. So it's literally just, it jumps, checks if we can do multi-boot, checks if we can do the CPU ID instruction, and checks if we can do long mode. And then it just jumps directly to long mode, basically. And so if you didn't know, protected mode, long mode, those are just the different operating modes of the x86 processor, x86-64 processor. Protected mode is 32 bits. When it boots, it starts in, I believe, real mode, which is 16 bits. And so we go from real mode to protected mode. Actually, I believe Grub puts us into protected mode. I'm using Grub as the initial bootloader now, as I did in my previous versions of k4dos. So Grub puts us into protected mode. When we try to jump to long mode, if it doesn't work, we jump back into protected mode. And set up some initial page tables, set up an initial GDT, set some control register flags, kind of like we did in the code over here. And then we jump to our GDT code segment, which is going to be in long mode. Long mode is 64-bit mode. So then we, long mode, again, we set some CR0 flags, some CR3 flags, load a new page table. And then we're in long mode. We load the offset to the kernel, and we jump to the kernel. There we go. Call kernel main. So, excuse me. So I'm using the multi-boot 2 protocol for my, excuse me again, for my kernel main. So, let's see there. I'm going to go back to main.rs. Yeah, this is now called kernel main instead of just _start. But essentially, no difference. It passes in a little magic parameter or a magic number that I very irresponsibly do not check. But, and then it gives me the information, the boot information that I booted with, kind of similar to the mine, where it has a memory map and that's basically all I use it for, is memory map. But I suppose I could use that to check the boot time and all that, but I had to get rid of all the boot time code and all that. I'm literally just including boot.s as a global assembly, by the way. That's how I ended up doing that in the last version. But other than that, it's mostly the same. I also have this VGA text module now that is ported from old versions of k4dos. However, I extended it by quite a lot in the process of porting NetHack over. So essentially, it's the text interface that you were seeing when we booted up QEMU. So just the code page 242, 232, something like that. What's that even called? That's gonna drive me nuts now. Let's see. IBM code page 437. Yeah, 437. IBM code page 437. So it's essentially just it's a character set for the IBM PC from back in the day, and is what modern processors tend to boot with to begin with, or at least that's what QEMU does. So that's what I do, you know. So yeah, so we can move the cursor all over. Well, first of all, we keep track of the cursor. We keep a virtual cursor on the X and Y position on the screen, row and column, all that jazz. And we essentially just set volatile bytes in raw physical memory to wherever we want them to be, starting at offset physical address 0xb8000, which is where VGA memory starts for the VGA text interface on this QEMU that I have. So yeah, and I have a bunch of exposed functions to do things like clear the screen, do a backspace, set the colors, set the cursor position, blah blah blah, clear until certain. These are all basically ANSI escape codes that I implemented. That we'll get into in a bit. And then most of the other work that went into this was in TTY, the RS. I had to completely overhaul the terminal interface, terminal emulator that I was using. This file is now 800 lines of code, but it's really not that bad. Honestly, most of it is stuff that I'm just not even using. That's only like the first 600 lines that are actually being used right now. But this let's see here. Yeah, so this is a big parsing function, 200 lines of code on its own, for the ANSI escape codes. And most of it's mostly the same, except I just replaced all the calls to serial print with VGA print. So how this works is essentially we're kind of like parsing whenever we write to the serial TTY, or I guess the VGA TTY now, but you get what I mean. Whenever we write to the TTY, we first we read the entire buffer in its entirety so that we can parse the entire buffer. We just read that into a heap vector, dynamically sized array. And once we have all that, we split it by the escape character, which is 0x1b in ASCII. So if his first byte is not the escape character, we don't start with an escape character, we print until we find an escape character. And then for each escape character, we check if it's if it's alphabetic at all, because if you didn't know, let's see, where's that page I was looking at? ANSI escape codes. Yeah, it was all you want to know about ANSI escape codes. Where was it? I should have pulled this up ahead of time in preparation, but yeah. So this article, I'll link in the description if I remember to. Basically explained this in a way that was really easy for me to understand. So the control sequences for ANSI basically are like function calls. And I didn't realize this until I was already halfway through writing a different version of this parsing function that just kind of read the bytes one by one. And it was a huge pain in my ass. But so they all start with 0x1b plus an open bracket. And then after that, you'll have one or more arguments separated by semicolons. And the arguments are all numbers. And And then after that, you'll have a alphabetic character that has a function name that identifies the function. So all these functions that we have here, things like move the cursor up would be a function capital A, with one argument, that being n, etc. These are all different things you can do with an ANSI compatible terminal, like Xterm or VT100 or whatever. Essentially what I'm doing here is I'm just matching against those different function names. In fact, that's literally what I'm doing, matching against the function identifier, and parsing the arguments if applicable, and doing what this thing says to do, what this article says to do. So, and that's been working great. So, as you see, there's lots of to-dos in here, all lots of unimplemented in here. This is all functionality that I still need to add, but good enough to run NetHack for now, so good enough for me for now. So, I don't think the color code stuff actually works, by the way, but it's whatever. So, yeah, that's how all that works. So to back up a bit, in order to get all of this working, and in order to know I needed all these things, I needed to first port NetHack to my operating system. So I'm going to quickly go over how I did that. It's actually in a hidden git ignore repository or folder. And spoiler alert, I ended up needing these other two directories as well, Linux headers and ncurses. You need to port those two. So if you never built NetHack from source, which I'm guessing most of you haven't, because who the fuck does that? If you know, so you're insane. You essentially have to go into these the sys folder in the repository root, and go to whatever category best fits your operating system. So I went to Unix because my k4dos wants to be as Linux compliant, compatible as possible. I basically just copied this entire folder because at first I tried using the stuff in the Unix folder, but it just wasn't working for me, and I didn't want to screw up anything with what was originally there. So I just made a new folder called k4dos, and I copied the context of the Unix folder. And this is where the magic happens, really. So what I changed with this makefile for NetHack, this is prepended to all the makefiles. This is the hint, the makefile hint, basically, the makefile header. What I did was I set my C compiler to the musl GCC script, which musl is the C library that I've been using this entire time to run C programs on my operating system. And I've used musl because it's very minimal. It doesn't use too many Linux-specific things that are super weird like libc does. Doesn't use things like futexes or at least not unless you tell it to, So it's very minimal. It's kind of designed for embedded systems, which my operating system kind of technically counts because I'm running on an emulator, I guess. So it's very nice. And they provide this handy script called musl GCC that just runs GCC, but tells it to use the musl C library instead, and musl libraries and static libraries and headers and all that. So other than that, all I changed really was I removed a bunch of defines, obviously. But I defined text static for C flags, for its compiler flags. I had this tech-d k4dos in case I needed to do anything with that, but I ended up not needing to do anything with that. And I added tech-d to define ANSI default. This took me a while to figure out, but this is why, because before it was trying to do all kinds of weird things, like do weird commands with the terminal and blah blah blah, and the stuff that I wasn't ready to implement into my operating system yet. So with the ANSI default, it would just use default ANSI escape codes, which were easy enough for me to implement in the end. So, and then I added to the L flags, to the linker flags, text static as well, and to add a library directory of my custom ncurses port, which I had to not port, but I cross-compiled it for the muscle target. That ended up working fine, thankfully. Yeah, so I cross-compiled ncurses. I told the NetHack to use that version of ncurses, and it compiled just fine. Honestly, it did. Like, I was really expecting this to take me a while to figure out, but honestly, once I figured out that I needed to just add this define by searching through the source files and all that. Thank you, ripgrep, by the way. Shout out to ripgrep. It's a command line tool that is like grep, but it's like insanely fast. It's easier to use, in my opinion. So what was I saying? Yeah, I added this define, and once I knew that I needed to add this define, and it built just fine using the standard install instructions that came with NetHack. So I copied its installation folder into my ISO image, or not my ISO image, but to my NetRamFS image. So you can see now we have this user games NetHack with all NetHack data files. And now we have NetHack on my operating system. So that was just a little quick overview. I still do want to get into the system calls and the task system and the scheduling system and all that I've implemented in my operating system. But this is what I've been working on lately. So I figured I'd put a video out to talk about it. So if you have any questions, please let me know in the comments. Also, I wanted to quickly announce that my GitHub for this project is now public. I should have put that at the beginning of the video. I totally forgot to. But GitHub is now public. You can check the code in the link in the description below. And that's about it. So thank you all for watching. I'll be back with another devlog very soon. Peace out.